Hello, today we're going to do a fairly easy integral. It's not that easy that it can be solved with like integration by parts, just only using those things. We do need some tricks here, but it's not as hard as the ones we've already done. So let's get right into it. We're firstly going to split this integral up into two pieces. So we're going to get the integral from 0 to pi over 2 of the natural logarithm of sine of x dx plus the second part of this integral. So the other bounds are going to be the integral from pi over 2 to pi of the natural logarithm of sine of x dx. So as you can see, all we've done here is we've split this integral up into two pieces, but it's still the same integral twice, and it's just the same integral in general. But now we're going to do a substitution here. So how are we going to do that? We're going to substitute x equals t plus pi over 2. Now it's important that we only substitute this in the second integral here. By the way, this also means that the dx doesn't change, dx equals dt, so that's pretty trivial here. But what happens to the bounds? So first of all, we're going to rewrite our first integral. So the integral from 0 to pi over 2 of the natural logarithm of sine of x dx plus, and then the bounds are going to change. So what happens when we plug in x equals pi over 2? Well, we're going to get that t is equal to 0, so the integral from 0, and then the same thing for what happens when x equals pi. We're going to get pi over 2, and then the natural logarithm of sine of t plus pi over 2 dt. Now, next up, we're going to notice that this second integral can be converted into another one, which is actually really useful for our calculation. So, again, we're going to rewrite our first integral, which is going to be 0 to pi over 2 of the natural log of sine of x dx plus, and then we're going to get a second integral from 0 to pi over 2 as well. Of the natural log of cosine, and this is the trigonomic identity we're going to use here. It's a pretty well-known one. If you don't understand this intuitively, look it up quickly. It's not too hard to get. So we're going to get cosine of t dt. Now the next substitution that we're going to do is completely trivial. We're just going to use a substitution to change the variable. So t is going to become x again. And this doesn't actually change anything about the integral. We just do this to make it easier to combine these two integrals. How are we going to do that? So first of all, the bounds are the same, so you can just add these functions together. Now, adding two logarithmic functions means we can multiply the content of the logarithmic function. So we're going to get the integral from 0 to pi over 2 of the logarithmic function of sine of x times cosine of x dx. Now, the next step is going to be to play around with this expression a little bit so that we can apply another substitution to get a really nice expression. So we have the integral from 0 to pi over 2 of the natural log of, and then we're going to do 2 times sine of x times cosine of x over 2 dx. So all we've done there is we've multiplied by 2 and divided by 2, so we haven't changed anything. Now, this integral can be converted completely into the integral from 0 to pi over 2 of the natural log of sine of 2x dx plus the integral from 0 to pi over 2 of the natural log of 2 dx. Sorry, this is not plus, but minus. So what we've done here is we've taken this expression 2 times sine times cosine x and written it as a sine of 2x. And on the other hand, we've used logarithmic rules to bring this over 2 or log over 2 as a minus and actually split it up into another integral. What we can also do is we can apply substitution on the first integral. So what substitution are we going to apply? We're going to have 2x equals u. So that means that 2 dx equals du. And from that, we can just substitute everything in. So we're going to get the integral from 0, that bound doesn't change, up to pi, that does change because we just multiply by 2, and then of the natural log of sine of u du, but then we have to take into account the constant that changes, so we have a half times that integral, and then also minus our simple integral from just now, minus pi over 2 times the natural logarithm of 2. Now the final thing we have to notice is that this integral, let's say we call it I, is actually the same integral as the integral we've got here. So I equals a half times I minus pi over 2 times the natural logarithm of 2. And if you can't immediately see that, let's just think about u and x as interchangeable here, and then you can see that these integrals are completely comparable to each other, and there's actually no difference. So now we've just got this simple equation which we could solve for I. So I minus 1 over 2I is equal to minus pi over 2 times the natural log of 2. And then this first part is obviously just a half times I, which means that I is equal to minus pi times the natural logarithm of 2. And that is our final answer. So we've now got that this integral, so the integral from 0 to pi of the natural logarithm of sine of x dx is equal to minus pi times the natural logarithm of 2. So that's our final answer. Thank you so much for watching. If you've got any tips for me, let me know down below. And till next time.